Hi, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to more examples related to factors of polynomials. So in this example, x minus 2 and x plus 1 are given as factors of the polynomial here. So we have a polynomial. This is a cubic function actually, okay? 2x cubed plus ax squared plus bx minus 5, and this example is particularly asking you to find the values of the constants a and b. So if x minus 2 and x plus 1 are both factors, therefore when you substitute x equals 2 into the function, the result will be 0. And if you substitute x equals negative 1 into this polynomial function, you will expect that the result here will also be 0. So we're going to do just that. So now substitute x equals 2. So here is 2 to the power of 3 plus a 2 square plus b times 2 minus 5, and the answer must be 0 because this is stated as a factor of the polynomial. Now we are going to continue solving this expression. So we have 2 to the power of 3 is 8 plus 4a, yeah, so this is 4a plus 2b minus 5 is equal to 0. Next, I have 16 plus 4a plus 2b minus 5 is equal to 0. And based on this, we can further simplify that to 4a plus 2b plus 11 is equal to 0, and this is my first equation. Now next is we can substitute negative 1 into this polynomial 2x cubed plus ax squared plus bx minus 5, and the answer should also be 0. So 2 negative 1 cubed plus a negative 1 square plus b negative 1 negative 5, and the answer must be 0. So here I have negative 1 to the power of 3 is negative 1, so it will be negative 2. This one will be positive, so it will be plus a. This is negative b. This is negative 5 is equal to 0. Next, I will have a minus b minus 7 is equal to 0, and this is equation 2. So based on equation 2 here, I can say that a is equal to b plus 7. So this is 3, and I'm going to substitute this into 1. Okay, so I'm going to substitute this into 1. Therefore, 4 times a, so a is b plus 7, so substitute that, b plus 7 plus 2b plus 11 is equal to 0. We're just going to solve what b is. So 4b plus 28, 2b, 11 is 0. 4b and 2b is 6b, 28 and 11 is 39. Okay, so that is 39 is 0. So 6b is negative 39, therefore b is negative 39 over 6, which is actually negative 6.5. Okay, so next, once you have managed to get what b is, we can substitute this into equation 3 here, so we can obtain the value of a. So now, therefore, A is equal to B plus 7, where B is negative 6.5 plus 7, and so A is 0.5. So those are the values of A and B. A is 0.5 and B is negative 6.5. Alright, next, so factorize this following expression completely, and in this case, we have actually we actually need to find our own factor to start with, and usually we can choose a simple factor. For example, we can choose either x minus 1 or x plus 1 or x minus 2 or x plus 2, something very simple to start with. Okay, so for this one, if x minus 1 is a factor, therefore if you substitute 1 into this expression, the result here will be 0. So now let us try and do that. So if I substitute x equals to 1, my p1 here will be 2, 1 to the power of 3 minus 9, 1 square plus 3, 1 plus 4. And you can see that this becomes 2 minus 9 plus 3 plus 4. So this is negative 7 plus 7, which is 0. So because of that, x is equal 1. So 1 here is the root of the polynomial function here. And because of that, x minus 1 is actually one of the factor. So once we have managed to find the factor, we need to go on and find the rest of it, complete the whole process in order to factor this polynomial function completely. So next, what we need to do is we are going to apply the long division process. Okay, so this is 2x cubed minus 9x squared plus 3x plus 4. And so we're going to take this one as a factor. So this is x minus 1. And so we're just going to continue with the process. Here we have, I need to find the value here such that when I multiply with x, I get to x cubed. So that would be 2x squared. 2x squared times x will be 2x cubed. 2x squared times negative 1 will be negative 2x squared. Subtract. So this term here will be gone, 0. Negative 9 plus 2 will be negative 7x squared. 3x is coming down, so plus 3x. Now, how do I get negative 7x squared? So I have to multiply that with negative 7x. Negative 7x times x will be negative 7x squared. Negative 7x times negative 1 will be positive 7x. Subtract. This term here will be gone. 3 minus 7 will be negative 4x. Now 4 is coming down. So in order to get negative 4x, I have to multiply x with negative 4. So negative 4 times x, negative 4x, negative 4 times negative 1 is positive 4. Subtract, and so the remainder is 0. So based on this, I can see that the expression here can be factorized into, okay, I'm going to write down the original expression, 2x cubed minus 9x squared plus 3x plus 4 can be factorized into q times d, quotient times divisor. So that will be 2 x squared minus 7x minus 4, x minus 1. And we are not done yet because this is actually a quadratic expression which you can further factorize it by inspection. So now we can see that in order to get 2x squared, I need maybe 2x and x. So if I multiply them, I will get 2x squared. 2x times x, I will get 2x squared. Next, I need to find the factor for 4 such that when I multiply, I get negative 4. So it could be 4 and 1. 4 and 1, okay, but I need to have negative value here. So this could be negative 4, positive 1. So when I multiply these two terms, I'll get negative 4. Okay, next if I cross multiply this, I will get negative 8x. Cross multiply this, I will get x. So negative 8x plus x, I will get negative 7x, which is in the middle. So I'm good with that. Now we can factorize that as 2x plus 1. So 2x plus 1. Next, x minus 4. And you can check if you are not confident enough. So if you expand this, you should be able to get the original expression on top here. Okay, so 2x times x is 2x squared. This one is negative 8x plus x will be negative 7x, and 1 times negative 4, you will get negative 4. So this is the answer to question or example 7.10, where it is asking you to factorize this polynomial function completely. So the method is by applying a long division process, but before that you need to guess the factor. So you can start with, you can consider something very simple like x minus 1 or x plus 1, x minus 2 or x plus 2. Those are simple factors that you can consider. Okay, you can try on. So in order to check whether this is indeed a factor, you need to substitute the value into the polynomial function, and if the result is 0, then that one is a factor, and you can use it to go on with the long division process. Complete the long division process, make sure the remainder is 0, and this quotient times divisor will be another way of expressing the polynomial function. So this is quotient and divisor, and then you can see that this can be further factorized into two components here. So once you have managed to get all that sorted out, then that is the answer to the example 7.10. Alright, thank you very much for watching. I'll see you in the next video.